Add the following two rational expressions. A minus 3 over a squared minus 5a plus a minus 9 over a squared minus 25. Now the first thing we should do when we're combining these, since these two denominators aren't the same, is that we need to factor each and to build the LCD from the factors. So let's take a look at the first one. The first denominator is a squared minus 5a, and you can factor an a out of that, right? So if you take an a out, what's left is a minus 5. Then for the second denominator, that's a squared minus 25, and 25 is a perfect square, right? So we can write this as a squared minus 5 squared, and you should recognize this as the difference of squares formula. So that's going to be a plus 5 times a minus 5. And then we want to build the LCD from the factors. And we do that by including every single factor without repeating it. So we have a times a minus 5 times a plus 5. And we don't have to write that second a minus 5 down. So this is the LCD. So now what we want to do is, since this is an expression, we want to make sure that each of the denominators is the LCD so that we can combine it. So let me rewrite this expression. So it's a minus 3 over a times a minus 5 plus a minus 9 over a minus 5 times a plus 5. So now we take a look at each of our denominators and we see what's missing in terms of the LCD. Now for the first one, we have the a and we have the a minus 5, but we don't have the a plus 5. So what we want to do is multiply the top and bottom of this rational expression by a plus 5. The reason we multiply the bottom by a plus 5 is so that we can have it look like the LCD. And the reason we multiply the top is so that we're essentially multiplying by 1. So we don't change the fraction. Now for the second one, we have the a minus 5. And we have, the a minus 5. And we have the a plus 5, but we need the a. So for the second one, we multiply the top and bottom by a. So now, let's combine. So a minus 3 times a plus 5, we can FOIL those, right? So this gives us a squared plus 5a minus 3a minus 15. And then, the denominator for this term is going to be a minus 5 times a plus 5. And then for the second, this is going to be a times a minus 9. And too late do I realize that my a's look a little bit like 9s, right? So this is a minus the number 9. So a times a minus 9 is going to give us a squared minus 9a. And that's over a minus 5, a plus 5. So now the denominators are the same. And we could use the rule that that we use for fractions, where if you have two fractions and you're adding them together and they have the same denominator, then the result is the sum of the numerators over that common denominator. So let's combine the numerators. So we get a squared plus 5a minus 3a minus 15 plus a squared minus 9a. And that's going to be all over that common denominator. So a minus 5, a plus 5. So now we combine like terms. There's an a squared and an a squared. So that gives us 2a squared. Let's see. there's a 5a, a minus 3a, and a minus 9a, which gives us minus 7a, right? Yeah, minus 7a. And then you can just write that lonely little minus 15 by itself. And that's all over the common denominator. So we've combined, but we still need to simplify. We need to see if the numerator factors into anything. So we get 2a times a. You know the signs are going to differ. So minus 5 plus 3. Let me check that because I'm not entirely sure. So factoring that back in, we get 2a squared minus 10a plus 3a minus 15. So that ends up giving you 2a squared minus 7a minus 15. So excellent, we managed to do that. And then in the bottom, get a minus 5, a plus 5. So now there's an a minus 5 in the numerator and the denominator that we can factor out and cancel. So what's left over is 2a plus 3 over a times a plus 5. And since there's nothing more to do, this is the final answer. And you don't need to worry about distributing that a back into the denominator because it's just going to give you extra work without giving you any more information. So you can just leave it like this.